This is Algebra Lesson 8.1, Recursive Routines. Imagine that a bug population has invaded your classroom. Every week, new bugs hatch, increasing the population. One day, you notice 16 bugs. 1 week later, there are 24. 2 weeks later, there are 36. 3 weeks later, there are 54. Record the whole number of bugs at the end of each week for 3 weeks in the table at right. So we started with 16. Next there were 24, then there were 36, then there were 54. Calculate the ratio of the number of bugs each week to the number of bugs the previous week. So we're going to take how many bugs there were in week 1, divide that by how many bugs there were in the starting week, week 0. And we'll calculate some more ratios just to make sure. And it looks like every one of these ratios is 1.5. Model the population growth by writing a recursive rule that shows the growing number of bugs. So we did recursive rules back in chapter 5. A recursive rule always tells me two things: where my pattern starts and how my pattern changes. My change is signed. It tells me to multiply, not just 1.5, but multiply by 1.5. We are going to check to see that this rule works. So I am going to get out my handy dandy calculator. I know that I started at 16, so I do 16, enter. My rule is telling me to multiply by 1.5. When I push my multiply on my calculator, the little answer pops up. And when I hit enter, it's giving me 24, which is the next entry in my table. And then enter gives me 36 again. And then enter gives me 54 again. And I can keep going to get the next 3 entries in the table. I'm going to start rounding these. I'll just say 273 and 410. So we can see that left unchecked, the bug population will continue to grow and grow and grow and grow. Number 5 says, what is the bug population after 20 weeks or after 30 weeks, and what happens in the long run? So I am right now at week 8. I can keep hitting enter as I count to get up to week 20. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. After 20 weeks, I will have over 53,000 bugs. And I can keep going up to 30 now. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. After 30 weeks, I have over 3 million bugs. And if I just let this keep going forever and ever and ever and ever and never ever called, the exterminator or sprayed or anything like that, I mean, technically they're going to just keep growing and growing and growing and growing and growing forever and ever and ever. I didn't really count that time, but I'm at 1.16 times 10 to the 11th. Remember, that means we're going to move our decimal 11 places, but in the long run, there are infinitely many bugs. Percent change. If you have a percent that is increasing, we can calculate our percent change by doing 1 plus the percentage. If we have a percent that is decreasing, we do that with 1 minus the percentage. So, a little example of that. If I am increasing 12%, I would do 1 plus 12% as a decimal, or if your calculator has a percent button, you can use that too. Tells me that my change is 112. Or say I'm decreasing 7%, I would do 1 minus 7% as a decimal. Remember, we just moved that decimal point 2 places. So 0.93 would be my change. Okay, I have 2 little examples. Example A says a half-life is the amount of time it takes an element to decompose to half its current state. The half-life of carbon is 5,730 years. If Karen has a 30-gram sample of carbon, how much will be left after 6 half-lives? So right now, I am starting at 30 grams. I am changing by multiplying by a half. How much will be left after 6 half-lives? So I'm going to go to my calculator and I will start at 30, change by 0.5, and after 1, 2, 3, 4, 5, 6 half-lives, I have less than half a gram of carbon left. Example B, Maria has saved $10,000 and wants to invest it for her daughter's college tuition. She finds an option that grows by 5% each year. Write a recursive rule and find what Maria's balance would be after 5 years. So Maria starts with $10,000. And to calculate the percent change, I need to use my percent change formula. And since I am increasing by 5%, I'm going to use the percent increase formula. I'll do that off to the side. We have 1 plus 5%, which we move that decimal 2 places, 0.05. 1.05 is the change. How much would there be after 5 years? Start, change, 1, 2, 3, 4, 5 years, $12,762.82. That's it for the examples. Good luck on the exercises, and please let me know if you have any questions.